Hello everyone, my name is İrem Bakacak. I'm a second year industrial engineering student. Today I will explain my Physics 102 laboratory project, which is named the linear relation between the currents and electromagnetic force. As we can understand from the project title, the aim of this experiment is to show the linear relationship between the currents of a coil and electromagnetic force, which is the common result of Biot-Savart law and the Lorentz force law. The equipment we need for this experiment is a coil to create a magnetic field, a DC power supply to apply voltage, a multimeter to measure the currents, a ball with a magnet and a rope, so a pendulum, a tracker to measure the distance, and a scientific calculator. Now I would like to inform you about the theoretical background of this experiment. Firstly, we know from Lorentz force law that electromagnetic force is linearly related with the magnetic field. Secondly, we also know from Biot-Savart law that magnetic field is linearly related with the current. Now, by combining these two laws, we expect to see a linear relationship between the current and electromagnetic force. In order to show this linear relationship, I looked at the free body diagram for the ball and decided that the electromagnetic force can mathematically be represented with tangent theta. In order to calculate tangent theta more easily, I decided to use an app called Tracker to measure the horizontal distance of the ball from the center and calculate tangent theta with this formula. First of all, I created my coil and placed it right next to my pendulum. Afterwards, I applied some voltages with my DC power supply in order to create a current on the coil and therefore a magnetic field and therefore an electromagnetic force on the ball. I applied voltages between 10 and 30 and observed the current's horizontal distance and calculated tangent theta and collected all these data in table 1. Then I calculated the ratio between tangent theta and current and collected the data in table 2 for each of the trial. Theoretically, I was expecting these numbers to be the same. Then I took the data in table 1 and created a plot which has current as x-axis and tangent theta as y-axis. As you can see from the plot, I achieved a linear graph with a constant slope, which is 0.117. Now I want you to notice that this slope I calculated is almost the same as the numbers I calculated in table 2 with small deviations. All these results prove that tangent theta and current and therefore electromagnetic force and the current has a linear relationship, which was my aim at first. And the main reason for the small deviations in table 2 is the errors in this experiment. The primary cause for these errors is the solenoid, since the solenoid was made by me and its coils were not perfectly made. This caused the solenoid to have an unstable magnetic field, which eventually resulted in unstable movement and therefore wrongly measured distance and wrongly calculated tangent. Also, the error percentages of multimeter and tracker creates the reason for data deviations. These deviations and errors can be minimized by repeating the experiment with a more regular solenoid, a more sensitive multimeter and DC power supply, and less air friction. Thanks for listening to me.